Homework for section 8.2. Question number 1. According to the February 2008 Federal Trade Commission report on consumer fraud and identity theft, 23% of all complaints in 2007 were for identity theft, consumer fraud, and 2008. Okay, let me write down 23%. Where for identity theft. Okay, assume a state had 386 complaints of identity theft out of 1590. Okay, 386, which is going to be our X. $386 out of N, 1590, right? I think it was, yeah. 1590, okay. Consumer complaint. Calculate 93% confidence interval for the proportion of all complaints complaints of identity theft in that state. So 93% interval for proportion. Okay. So we need to find proportion for confidence level 93%. Okay. All right. So let's start working. What is the correct parameter for this problem? Parameter symbol. Since we are talking about proportion we mark down with P. Proportion for population, that's P. Proportion for the sample, it's a P hat. This one is P hat. This is P hat. Proportion for samples, but since it's asking for parameter, it's a characteristics for population. Okay, what is the wording of the parameter in the context of this problem? So obviously it will start with the word percentage, because proportion, nothing else but percentage. The percentage of all consumer complaints. Where is it? Of all, here it is. I can choose 1590 because it randomly selected consumer complaints. The percentage of the 1590 randomly selected consumer complaints, that means that's a percentage of sample selected people, but we need percentage P represent percentage of all consumer complaints. Okay, next assumptions. So we need to find if this is qualitative or quantitative, because if it's qualitative, then we are using percentage for qualitative proportion. If it would be quantitative, then we would use z-score. Okay, z-test. We would use z-test for quantitative information. For qualitative information, we're using proportion. So since we are dealing with proportion, evidently it's going to be qualitative. This question should be number 1, because P would come out from this answer, qualitative. Okay. Okay. The qualitative information was collected from each object. What condition do we need to check? All right. Condition that we need to check is going to be the first one, then n times p hat has to be more than 10. That's a condition number 1. Then n times 1 minus p hat is going to be greater than 10 also, because that's a n times q hat. 1 minus p hat is a q hat, complement of np and nq. Q is equal 1 minus p. Okay, both cases. And the third condition is population size has to be at least 20 times greater than sample size. Those are our conditions. Now, next we are going to check our assumption. So n times p hat. Our n that we have is 1590. So our p hat is equal x divided by n. Actually, we're going to go easier way. X from here is equal n times p hat, and that's what we need, right? N times p hat. And we are given x is 386. So we just might as well place here 386. Here it is. 386. Okay. Moving here, which is, obviously, we are checking if it's greater than 10, right? N times p. See, this is among the conditions, which is going to be greater than our 10. Okay. N times 1 minus p hat. Let's see. We are checking n times 1 minus p hat. So that's going to be, let me see how easier way we can do. Okay. No, p hat, okay, n is 1590, and 1 minus p hat is 0.23. So we are getting 1590 times 1 minus 0.2 is 0.8 minus 3, 0.77. Okay, so 1590 times 0.77, and we are getting 224. Okay, it's not coming. Oh, here it is. Thousand 224, which is obviously it's greater than 10, right? We are checking that one also. Okay. Next, n. That's a size of population. Usually when it's not given, it is in the previous problems, it was recommended to place 1, 2, 3, 4, 5, 6 zeros, million. 1, 2, 3, oops, 4, 5, 6 zeros, which is the greater equal how much is our information here? It has to be, n has to be greater than equal 20n, right? So 20 times 1590. So 1590 times 2. It's going to be 31,800. So let's enter. Here. 31,800. Okay. Now, if no n is given, we take 1 million. Here it is. It's given already. So, the conditions are met to use, and those are conditions for first one, proportion, z interval. First one is proportion, and z interval. So we're going to use proportion. The symbol and value of the point estimate on this problem are as follows. So we have p hat as a point estimate. P hat is a point of estimate for proportion. We already know that, right? So p hat is equal. How much is it? P hat, leave an answer as a fraction. Okay, p hat is equal. Here it is. I have this number that's equal 386, but they want in the form of fraction. We can write down 386 over 1590, right? So it's gonna be fraction 386 over 1590. All right, let's check so far how we did, because with this system we never know where what silly mistake can be. Oops. Well, this is clear. It has to be 0, 0, but 1, 2, 3, 4, 5, 6. Okay, but this one, I'm curious. 1, 2, 2, 4. We just solved it. N times 1 minus p hat. Let me do the math again. 1 minus 0.23, that's 0.77, and time 1590 times 0.77, and we are getting 1224. So there is no other solution here can be, so answer is wrong. Why don't you mark down, please, that first question, first problem, and this question to check. If you get wrong, so just text me, okay? So I can give you credit for that. Next, the conditions are met to use, okay, we have here, all right, 386 over 1590, that is also correct. So, moving on. So next, what do we have to do? We need to find the interval of estimate. Interval of estimate for proportion P. Here we are heading to our StatCrunch. I have already prepared StatCrunch. So we are clicking Stat, and then here it is. We go, it's below T-Stat, proportion stat. We are choosing with summary. It should ask on your on the desktop. It's asking one sample or two samples. You choose one sample because we are working with with one sample. So proportion stats. We are going to work with summary. We don't have raw data, right? So number of success. This is our X 386. Total number of observations. This is our sample size. It was 1590, correct? Hypothesis test. We don't have hypothesis test, so we leave it the way it is. Actually, what we need, confidence interval. Our confidence interval is 93, right? Not 95. I fixed it. Put 93, and we go to compute. And here we go, L limit, low limit, 0.223, let me write down, 0.22328, and rounding 5, and upper limit, 0.26224, okay, it's gonna be 50 if I round it, 2250. Okay, let's move to our math. Oh, 3 digits, okay, 3 decimal, they want 3 decimals, so it's going to be 0.223, 0.223, and here it's going to be 0.262, 0.262, we have it, and we are 93%, because our confidence interval 93%, we are confident, okay, we are confident that percentage of all consumer complaints that are for the identity consumer complaint in the states that are for identity theft, here it is between 0.223, that's we convert into the percentage is going to be 22.3, and it's going to be 26.2. This 0223 and 0262, it's decimal notation. We represent it in the format of percentage. Let's submit. See what we have here. Oh, this one, okay, everything correct. All right, all is good. We are good. Now, question number 2, I went over. It's exactly same as first one. So following first problem, you can solve question number 2. And then the same way you can solve, I believe, question number 3. That's right. If something is wrong here, is not the same or similar, rather saying, just contact me right away. But I believe it's question 2 and 3 similar to 1, so you can use a solution of example 1. You can use it to solve and 1 and 2 and 3. Now 4 is a different story. I'm going to solve 4. It's a different problem. A scientist claims that more than 4% of mammals are monogamous. For which confidence interval should you reject null hypothesis? Okay, more than 4%. So null hypothesis, we need more than 4%. That's going to be alternative because equal sign there is missing. So it's going to be proportion or average mu. No, it's percentage, so it's going to be proportion, okay? So proportion is more than 4%, which means for null, we put usually equal. But instead of equal, you have to assume that it at most 4, so it's going to be equal or less complement, because otherwise, I don't know, some textbook put only equal, but I think this would be more correct, because if you put only equal, then where is going the portion of less, right? It's still, it's correct as long as equal sign is present, then we are good. So let's read one more time. It's asking for which confidence interval should we reject null hypothesis? Okay, very good. We need to figure it out which one is going to be in the form of rejection. Okay, so we know that null and alternative are complements, meaning if this is true, then this is going to be false. If this is false, then this is going to be true. So rejection, meaning it's going to be false, right? It's a synonym to false. That means we need to have this alternative one true, which is the true is that proportion is greater than 4%, right? And which means the false is going to be 4% to reject, less or equal 4%. So that means we need to find interval that is at least at a maximum 4, or even better, less. So first one, 0.029, that fits, but 0.051. So what I'm looking, low boundary fits, it's less than 4%, but upper boundary, it's only this one. The rest is 5.5%, 6%, 5.1%. Therefore, the answer is going to be the last one, 0.02, 0.03. Bingo. Okay, I'm done with 8.2, and I'll move to record 8.3.